Orbital refueling is complicated. It takes a lot of launches, and even now, it's still the best option SpaceX and NASA have for getting humans to the moon. But what if it didn't have to be that difficult? What if I told you Elon Musk has an idea that's surprisingly straightforward and could make the whole process twice as easy? Sounds too good to be true, right? Well, let me introduce you to this new Starship concept. Every Starship mission to the moon currently needs around 10 to 15 tanker flights just to load up about 1,200 tons of fuel in Earth orbit before it can even leave. And yeah, you don't need to be a NASA or SpaceX engineer to see that this is pretty complicated. It creates a lot of chances for things to go wrong. On top of that, the fuel itself is super tricky to deal with. These cryogenic propellants have to stay extremely cold, and even small temperature changes can make some of them slowly boil off. So not only do you need a lot of tanker launches, but they also have to happen close together to avoid losing too much fuel. Luckily, as mentioned earlier, Elon Musk has a pretty straightforward idea to deal with this. Just make the rocket bigger. The idea is pretty simple. The bigger and more powerful the rocket is, the more fuel it can carry in a single trip, so you end up needing fewer refueling flights overall. Now, that's obviously easier said than done, but SpaceX is actually working on it. Recently, Elon has been talking more about a new version of Starship, often referred to as V4. He posted on X recently that Starship V4 could reach around 10,000 metric tons of thrust at liftoff, or about 22 million pounds of force. That's roughly 3 times more powerful than the Saturn V. What's interesting is that the current version, V3, hasn't even fully flown yet, and they're already planning ahead. To hit those numbers, V4 would likely be a much bigger vehicle, possibly close to 150 meters tall, with a liftoff mass of around 7,500 tons. The upper stage would also be stretched, meaning more fuel and a lot more capability overall. That could push payload capacity to over 200 tons to orbit, which is huge, not just for things like Starlink, but especially for missions to the Moon and Mars. The big advantage here is fewer launches needed to refuel in orbit. So how much of a difference are we talking about? According to Musk's estimates, a Starship V4 tanker could deliver over 200 tons of propellant per flight. That means instead of 10 to 15 launches, you might only need around 5 or 6 to fully refuel a lunar Starship. And just like that, the number of required launches gets cut in half, which makes the whole mission a lot more practical. I know some of you might be thinking, just making the rocket taller shouldn't magically let it carry way more fuel. And you're right. With rockets, it's not that simple. You need fuel to carry payload, but you also need fuel to carry that extra fuel. And it kind of snowballs from there. So the real trick isn't just making it bigger, it's making the whole system more efficient, especially when it comes to refueling ships in orbit. One of the really interesting details about V4 is the engine setup. The upper stage could get 3 extra vacuum Raptor engines, bringing the total for the full stack to around 42. On top of that, there's talk of upgraded Raptors pushing up to 300 tons of thrust each. That's what allows the booster alone to generate close to 10,000 tons of thrust at liftoff, about 3 times more than the Saturn V. And that kind of power is what makes the bigger, heavier V4 design actually work, letting it carry a lot more propellant into orbit in a single launch. Alright, so now that we know they're already planning a bigger Starship, it's fair to ask, is V4 as big as it gets, or can this thing go even further? And honestly, it probably can. Elon Musk has been thinking about scaling Starship up for a long time. As he once put it, size does matter. Back in 2019, when people were asking about a 12-meter version, he mentioned that a next-gen system could be closer to 18 meters in diameter. To put that into perspective, the current Starship is about 9 meters wide, so 18 meters would be double the diameter. That would make it wider than the Saturn V, around 10 meters, and even bigger than the Soviet N-1 rocket, which was about 17 meters. And this isn't just about making a giant rocket for fun. If you double the diameter while keeping roughly the same height, you get about 4 times the internal volume. That means way more fuel and way more payload, potentially enough to launch something as big as a full space station in a single mission. If you also scale up the height, you could be looking at payloads in the range of 500 to over 1,000 tons to orbit, which is just insane compared to anything flying today. But of course, going bigger brings big challenges. A rocket that large would need way more fuel, a much stronger structure, and, most importantly, a huge increase in thrust just to lift off. For something like an 18-meter Starship, SpaceX might need over 100 Raptor engines to make it work. Building an 18-meter Starship is not something SpaceX can just do overnight. It would basically be an entirely new rocket. They would need bigger factories, larger storage tanks, and thicker materials. Launch facilities would also need major upgrades, since the heat and force from so many engines firing at once would be extreme. Even the current launch tower system might not work for a vehicle this large, meaning SpaceX could have to rethink how the rocket lands. Transporting something that big is another issue. It would likely be too large to move using existing roads or ships, so SpaceX might need to build and launch it directly at the same location. On top of all that, there are regulatory challenges. A rocket of this size would take years of environmental studies and safety approvals. The impact of noise, shock waves, and emissions would all need to be carefully evaluated before it could ever fly. So why think about building something this big in the first place? The answer is Mars. SpaceX wants to send large numbers of people and huge amounts of cargo to build a permanent settlement there. Right now, that plan would require thousands of Starships and an enormous number of refueling missions in orbit, which is incredibly complex. A much larger Starship could simplify everything. If each ship can carry 4 times more, you would need far fewer launches. Missions that might have required around 1,000 ships could drop to just a few hundred, and the number of tanker flights could be reduced by thousands, possibly even removing the need for fuel depots in space. This kind of scale would also help with building infrastructure. A Mars colony needs habitats, equipment, food, and supplies, all delivered in bulk. A bigger Starship means fewer launches and faster progress. The same idea applies to the Moon, where a single launch could deliver large parts of a base, speeding up efforts to establish a permanent presence there. So what do you think? Will SpaceX ever build an 18-meter Starship? And if it does happen, could it finally make orbital refueling unnecessary? Let me know what you think in the comments. It's always fun to talk about future Starship versions and everything they might be capable of. But right now, the spotlight is still on Starship V4, especially its ability to refuel in orbit. SpaceX is aiming for a full ship-to-ship demo this year. And even though this is something that's never been done before, we've now got a pretty good idea of how they plan to pull it off. The main goal is simple. Move super-cold propellant from one Starship to another while they're both in orbit around Earth. For the first demo, they're aiming to transfer at least 10 tons of liquid oxygen. That might not sound like a lot compared to the total fuel load, but it's enough to prove that the system works. If they can do that reliably, it unlocks everything. Moon missions, Mars missions, and long-duration flights that just wouldn't be possible otherwise. The tricky part is that this all has to happen in microgravity. In space, liquids don't settle at the bottom of a tank as they do on Earth. They float around. That makes fuel transfer a lot harder than it sounds. So one of the key things SpaceX needs to prove is that they can control the fuel, keep it stable, and move it cleanly from one ship to another without leaks or major losses. To deal with that, both Starships will use small thrusters to create a tiny bit of acceleration, just enough to gently push the fuel in the right direction. It's basically faking gravity for a moment so the liquid behaves more predictably. Another big challenge is keeping everything sealed. These fuels are extremely cold, and space is a vacuum, so even a small leak could ruin the whole process. The docking system has to connect both ships tightly, almost like plugging 2 pipes together in orbit, while handling extreme temperatures and pressure differences. Once docked, the transfer itself doesn't rely on complex pumps. Instead, it uses pressure. By slightly increasing the pressure in the donor ship's tank, the fuel naturally flows into the other vehicle. It's a simpler and more reliable approach, especially in space where fewer moving parts are always better. Speed also matters a lot here. SpaceX is aiming to complete a transfer in about 1 to 2 hours. The faster they can do it, the less fuel they lose to boil off, since these propellants slowly evaporate even in space. That's especially important when you consider that a full mission might need 10 to 15 tanker flights. To make sure everything is working, both ships will be packed with sensors tracking pressure, temperature, and flow rates in real time. The goal is to keep fuel losses under 1%, which would be a huge win and prove the system is efficient enough for real missions. There are also a bunch of smaller tests happening alongside the main transfer. For example, they'll move fuel between internal tanks to simulate landing operations, test new sensors that measure how much propellant is left, and study how well the tanks keep fuel cold over longer periods in orbit. All of this builds toward one thing: making sure Starship can handle refueling not just once, but many times in a row. The mission itself will involve 2 separate launches. One Starship goes up first and waits in orbit. Then, a few weeks later, a second one launches, catches up, and docks with it automatically using advanced sensors, similar to the systems already used on spacecraft today. After that, they perform the transfer, gather all the data, then undock and safely re-enter Earth's atmosphere. If this works, it's a huge step forward. It means Starship can be refueled in space, which is the key to making deep space missions actually practical. Without this, going to the Moon or Mars with a fully loaded Starship just isn't realistic. At least, for now. Did you know that more than 97% of people watching aren't subscribed yet? So from one spaceflight fan to another, hit that subscribe button. It really helps and keeps me motivated to bring you the latest updates on everything space. Thanks.